Welcome back, dear children. Now we will move to our 8th chapter, current electricity. Okay. So first we have an introduction about the charges. Already we learned that there are two different types of charges. Which are they? Positive and negative, isn't it? Positive charges and negative charges. Also we learned that like charges always repel and unlike charges attracts each other. Now, which letter is used in order to represent charge? Do you know? Q. Okay, it can be either capital Q or small letter q. Q is the letter which is used in order to represent charge of a body. Then, what about the unit for charge? Charge is measured in coulomb. Coulomb is the name of a scientist. Okay. Since Coulomb is the name of a scientist and I wrote the symbol, I have used a capital C. Else, if you are writing Coulomb as such, you have to start it with small letter. Okay. Now, when you are considering the charge on a body, normally we will say it as the excess or deficiency of electrons present in it. Okay. Charge on a body can be represented either as the deficit of electrons or the excess of electrons in it. And for this, in order to find the number of or charge of a body, we have an equation. Q is equal to plus or minus Ne, where Q stands for the charge, then N means number of electrons and E is the charge of an electron. Already I told you the charge of a body will be generally represented as the deficit or excess of electrons. That is why we are writing it as Q equal to plus or minus Ne. Now, in a body, if the number of electrons are less, we will write it as Q is equal to plus Ne because it has more number of positive charges. If the number of electrons are more in a body, we will write it as Q is equal to minus Ne, where Q is the charge, N is the number of electrons and E stands for the charge of an electron. How much is the charge of an electron? It is minus 1.6 into 10 raised to minus 19 coulomb. Minus stands for negative, that is electron. Okay, since electrons are negatively charged, you are putting the simple minus there. The magnitude of charge of an electron is 1.6 into 10 raised to minus 19 coulomb. We are putting a minus sign to represent that it is an electron. If it is a proton, 1.6 into 10 raised to minus 19 coulomb itself is the charge, but there what we will say, plus sign will be there because number of protons are more. Okay. So if number of protons are more, plus sign. If number of electrons are more, minus sign. But magnitude in the case of charge of an electron as well as charge of a proton are equal. Then when we consider a conductor, we will be having many charges in it and these charges are distributed around the or in the whole body. But when you are considering an insulator, the charges are stationary. They can't move. Okay. So the charges present in an insulator will be static, whereas the charges present in a conductor are free to move. So what all things did we learn? We are having two different types of charges, positive charges as well as negative charges. Like charges always repel and unlike charges attracts each other. Charge is represented by the letter Q. It can be either capital or small letter. Its unit is coulomb. Then charge of a body will be generally represented either as the deficit of electrons or as the excess of electrons. So for that we have an equation. Q is equal to plus or minus Ne, where Q is the charge, N stands for the number of electrons and E stands for the charge of an electron. So charge of an electron is how much? 1.6 into 10 raised to minus 19 coulomb. Since it is an electron, normally we will say minus 1.6 into 10 raised to minus 19 coulomb. So if a body is having excess electrons, the equation is Q is equal to minus Ne, and if it is having excess of protons, Q equal to plus Ne. Then when you are considering an insulator, the charges present on it will be static. Whereas in the case of a conductor, the charges present will be movable. Okay, they can move. So is it clear about the charges? Now we will move to the next part, that is electric current. Okay, so how can you define electric current? Electric current is defined as the rate of flow of electrons. Okay, rate of flow of charges or rate of flow of electrons is known as electric current. Current is represented by the letter either capital I or small letter I. Okay, I stands for electric current. Then I told you it is rate of flow of charges or electrons. If the word rate comes, what should you do there? Divide the equation with time, isn't it? So rate of flow of charges, charge is Q, rate means dividing with time. So we have the equation I is equal to Q by T. Okay, so what is electric current? Electric current is the rate of flow of charges. Okay, so I is equal to Q by T. And from here, what about the unit for current? Unit for charge is coulomb and unit for time is second. And this coulomb per second is known as what? Ampere. It is also the name of a scientist, and since I wrote the simple, capital A is used. If you are writing ampere, it should start with small letter. Okay. So rate of flow of charges is electric current. I is equal to Q by T. Its unit is ampere. Now, how can you define 1 ampere from this? Usually, definition of the units will be asked in the board exam. So, you have to study the definition for the units. And it's simple. If you know the equation, you can directly say the definition. How can you define 1 ampere? 1 ampere is the current which flows through a circuit when if 1 coulomb of charge passes through it in 1 second. If 1 coulomb of charge passes through a conductor in 1 second, then you can say that 1 ampere of current is flowing through that conductor. Okay, so once you are thorough with the equation, we can give definition for the unit. Current will be 1 ampere only when 1 coulomb of charge flows in 1 second. Then only you will get current as 1 ampere. So is it clear? Now when you are considering the flow of current, in the case of metals, okay, in the case of metals normally, or in the case of conductors, generally metals means they are the conductors. In the case of conductors, who are the charge carriers? We are having the free electrons, isn't it? Due to the movement of free electrons, electric current is produced in the case of a conductor. But when you are considering an electrolyte, there will be positive and negative ions. And the movement of positive and negative ions makes electric current. Okay. Then, we learned an equation for Q. What was it? Ne. So, you can substitute it here. So, we'll be getting one more equation. I is equal to Ne by T. Okay. So, now we have two different equations for calculating current. Either Q by T or Ne by T. Then, one more thing you can remember. Current is actually a scalar quantity. Okay. We already learned about scalar and vector quantities. Current is a scalar quantity. So, is it clear about electric current? Electric current means it is the flow of rate of flow of electrons makes electric current represented by the letter I. So I is equal to Q by T. Its unit is coulomb per second. Coulomb per second means it's ampere. Then since we have Q as NE, you can write the equation as I is equal to NE by T. Then you have to learn the definition for 1 ampere. Okay. Now, so we learned about charges, current, and which is the next thing? We have learned all these things last year. We had a chapter, isn't it? Current, electricity, same chapter was there. And all these things were discussed in that chapter. So which is the next term? Next we have the potential difference, isn't it? So next we will move to potential difference and electric potential. So two things are coming there. What are they? Potential, electric potential at a point as well as potential difference. So already we learned that like charges always repel and unlike charges attracts each other. So it's very difficult to move one charge in the vicinity of the other charge, because either there will be attractive force or there will be repulsive force, isn't it? So it is difficult in order to move a charge in the vicinity of another charge. So we have to do some work in order to move it. How much work has to be done in order to move a positive test charge from infinity to a point? The work done in order to move a charge from infinity to a point can be called as electric potential at that point. So this is what we learned last year, and in this year it is given as a test charge, positive test charge. Test charge means actually a charge of small value. Okay. A charge of small value can be called as test charge. So how much work is done to move a positive test charge from infinity to a particular point, that can be called as electric potential or potential at that point. It is represented by the letter V, isn't it? So what will be the equation to calculate potential? Work done to move a charge. So V equal to W by Q. So work done in order to move a test charge, positive test charge from infinity to a point is called potential, electric potential at that point. It is given by the equation V equal to W by Q. What is W? Work. What about the SI unit for work? It is joule. Then what about the SI unit for charge? Coulomb. So joule per coulomb. Joule per coulomb is volt, represented by capital V. So is it clear? Potential at a point V equal to W by Q. Now when we need a definition for volt also. Okay. So with this equation, how can you define 1 volt? Or when can you say that the potential at a point is 1 volt? Okay. The potential at a point is 1 volt when 1 joule of work is done in order to move 1 coulomb of charge from infinity to a point. Okay. So when you are moving 1 coulomb of charge from infinity to a point by applying or by doing 1 joule of work, we can say that the potential at that point is 1 volt. Okay. So just study the equation. From that you can give the definition for volt. Okay. So that is about electric potential. Now, when you are considering current flowing between 2 points or 2 ends, we don't want to study about the potential at each point. In that case, we have to consider the potential difference between the two, isn't it? Already we learned that current will flow. Flow of electrons makes current, and current flow will take place only if there is a difference in potential between the ends, isn't it? That is, in one end we need more number of negative charges and in the other end we need less number of negative charges, and flow of electrons makes current. If this difference in potential or difference in the number of electrons is there, then only electric current can flow. Okay, so for the current flow we need a potential difference. So what is the definition for potential difference? It is the work done in order to move a unit positive charge or unit test charge from one point to another. In the case of electric potential, work done to move from infinity to a point. But in the case of potential difference means we are considering the difference in potential between 2 points. So how much work has to be done in order to move a positive test charge from one point to the other point? That is known as potential difference. So if you are moving a charge from A to B, let A and B are the 2 points, then what you can say, potential difference is VA minus VB. And here also it is the work done. We are having the same equation, W by Q. Okay. So potential difference between 2 points is actually the work done to move a unit test charge or a unit test positive test charge from one point to another. Okay, how much work is done? That is why W by Q. So here also what is the unit? It is volt. And if you are giving definition on the basis of potential difference, what can you say? 1 volt is the potential difference between 2 points if 1 joule of work is done to move 1 coulomb of charge between the 2 points. Okay. So with the equation, we have to define it. So is it clear? We have discussed about electric potential and potential difference. So what is electric potential? It is the work done in order to move a positive test charge from infinity to a point. Potential difference means work done to move a positive test charge from one point to another point. In both the cases, the equation is W by Q, work done by charge. Okay. And what about the unit? Unit is volt. So is it clear about potential difference? Now, after potential difference, what should we learn? What is the next term? Current, charge, current, potential difference, and the next one is about the resistance. Okay. So we will check what is resistance. The obstruction offered to the flow of current in a conductor can be called as resistance. Okay, resistance means tarisam. So the obstruction offered by the conductor to the flow of electrons. So in a conductor, electrons will be flowing, and this flow of electrons produces electric current, isn't it? So the conductor itself offers some resistance or obstruction to the flow of current, and that obstruction is known as resistance. Now we will check what is the reason for resistance. So I am considering a conductor. Okay, a piece of wire, a part of wire is taken. So inside a conductor, we will be having many positive ions. Okay, many positive ions will be there, and these positive ions are actually fixed. Okay, positive ions are fixed. Then again what we have? We are having many free electrons. And what about these electrons? These electrons are free to move. So they are always in random motion. Okay. So when you take a conductor, it consists of many positive ions. These ions are fixed. Okay. Then we are having many free electrons. These electrons will be in random motion. Okay. So will any current be there? No. current will be produced only if the electrons move in a particular direction. In this case, the electrons are in random motion. Angotu ingotu. Okay. So not in a particular order. So now current is there. Simply the electrons are moving here and there. Now we are going to connect it to a cell or a battery. So I have connected it to a cell. This is the bigger one is always the positive terminal. Smaller one is the negative terminal. Now when it is connected to a cell or a battery, what happens? Electrons are negatively charged. These positive charged ones are fixed. Negatively charged electrons will be attracted to the positive terminal of the battery. So all these electrons starts moving in, let this be A, this be B. So the electron starts moving from B to A. Okay. And what about the path for the electrons? Is it free? No. In between you can see many positive ions. So when these electrons are moving towards the positive terminal, it hits on the positive ions present there. So there is an obstruction in the flow of electrons. Okay. So they can't easily flow. When they are moving towards the positive terminal, they will hit with the positive ions as well as on the walls of the container. And this is the actual cause of resistance. Okay. So already I told you, resistance is the obstruction offered by the conductor to the flow of current. At first, electrons will be in random motion. Once it is connected to a cell or a battery, electron starts moving towards the positive terminal. When they are moving, what happens? It hits with the positive ions as well as walls of the container. So this is the obstruction caused. Okay. So is it clear about resistance? Okay. Now the next thing is about Ohm's law. This also we learned last year. Ohm's is the name of the scientist, isn't it? So he found that there is a relation connecting current and potential difference. So already I told you, when a potential difference is maintained between the ends, then only current flow takes place, isn't it? So the relation connecting the current flowing in a circuit as well as the potential difference is made by Ohm, and it is known as Ohm's law. Ohm's law is not valid always. It is valid only at constant temperature. Okay. So when we state the law, the first thing what we have to say is at constant temperature, because this is valid only at constant temperature. Okay. So according to Ohm's law, at constant temperature, the current flowing through a circuit is directly proportional to the potential difference across its ends. Okay. So if the temperature is constant, the current flowing through a circuit depends on the potential difference across the ends. If the potential is more current flows through it. If the potential is less current. Okay. So we have the relation V is proportional to I. Okay. V is proportional to I from Ohm's law. Potential difference is directly proportional to the current. Now I am removing the proportionality sign and I am giving equal. That means I have to introduce a constant, and that constant is R, which is the resistance. So normally we will say it as V is equal to IR. If I say, write RI or IR, both are same, but V equal to IR. That is what normally we will say. Okay. So according to Ohm's law, V is proportional to I, or V is equal to IR, where R is the resistance. R is the constant here. Okay. So is it clear about Ohm's law? When we say Ohm's law, first you have to say at constant temperature. Then only it will be correct. Okay. Now, if current is 1 ampere, if I is equal to 1 ampere, then V will be equal to R. That is, potential difference will be equal to resistance when at when the current flowing through it is 1 ampere. Now, about the unit for resistance. Ohm is the unit. This is the symbol for ohm, and ohm is the unit for resistance. Okay. So, if I write this equation in terms of R is equal to V by I. So, how can I define 1 ohm? 1 ohm is the resistance offered when 1 ampere of current flows through a circuit with potential difference 1 volt. Okay. 1 ohm is the resistance offered when 1 ampere of current flows through a circuit with potential difference 1 volt. So, is it clear, children? We have just discussed the terms which are very, very important in the case of electricity. Then about Ohm's law. Okay. Now, I'll tell you the homework questions. You can take page number 186, exercise 8A, till question number 9. Okay. Till question number 9, you have to write the answers. Page number 186, exercise 8A till question number 9. So, complete this for the next Google Meet. Okay. So, thank you, children.